Section 3.5, implicit differentiation. So all of the functions we have differentiated so far have been y equals something with x's in it, or f of t equals something with just t's in it. But what if it's not that straightforward? What if it is something like x squared plus y squared equals 25, a circle, or x cubed plus y cubed equals 6xy. Well, the x squared plus y squared is 25. We could actually divide into two pieces and differentiate the top half of the circle and the bottom half of the circle. Voila. But that other function that I just mentioned, x cubed plus y cubed equals 6xy, is a little loop-de-doo, and that is not so easy to divide into pieces. You would have to divide it into three functions. Luckily, we don't have to do that. We can do what's called implicit differentiation. So we just differentiate both sides as functions of x and use the chain rule. So, example 1. Let's do if x squared plus y squared equals 25, find dy dx. So I'm going to write that down. And then we'll find the equation of a tangent line. So, derivative of x squared with respect to x, 2x. Derivative of y squared with respect to x is 2y times dy dx. And then the derivative of 25 is 0. So I can isolate dy dx by subtracting 2x from each side. Let's see, I lost my dy dx. Let me fix that. Divide both sides by 2y. And I'm just going to simplify it to negative x over y. So the next thing we're asked to do is to find the equation of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. So we have a point, and we can calculate our slope. We evaluate dy dx at the point 3, 4. So it would be negative x over y. And now it's easy to just write down the equation. Y minus the y coordinate, slope x minus the x coordinate. I'm going to pull up Desmos and graph this thing. So I entered the equation of the circle centered at the origin with radius of 5. I plotted the little point, 3, 4. And then I entered our equation for our tangent line that we came up with, and it's perfect. Awesome. Let's look back at our pretty solution. So you can always go through that. Let's look at example 2. Now we're going to find the derivative of this fancier one, the folium of Descartes. Of course, everyone's heard of that. Example 2, we want to find y primed if x cubed plus y cubed is equal to 6xy. And we're going to make ourselves a little instruction sheet as we go through this one. So, first thing we do is take the derivative of everything with respect to x. So, step 1, differentiate with respect to x. So first term is a function of x. Derivative's just 3x squared. Second term requires the chain rule. Y is the outside function. Actually, y is the inside function. Cubing stuff is the outside function. And here we have a product. So first, I'm calling 6x first, and I'm calling y second. So 6x times the derivative of y plus second times the derivative of first. So y times the derivative of 6x is just 6. Let's go ahead and close you down for now. Okay, so we've differentiated with respect to x. We could simplify that a little bit, but I'm going to go ahead and do that together with step 2, where I get everything with dy dx on one side of the equal mark. So, doesn't matter which side you put it on. If there's a minus sign, then sometimes I will arrange things so that I end up with more positive signs just because I'm a positive person. But it doesn't really matter. So I'm just going to leave my 3x squared on the left-hand side and subtract 3y squared dy dx from both sides. And I'm going to write y times 6 as just 6y. And now I'm going to subtract 6y from each side and pull it over there with the 3x squared. You could have done that all in one step. I was just doing it nice and slow our first go round. So now we have everything with dy dx on one side and everything that doesn't have dy dx on the other side. Now I'm going to factor out dy dx. So, left-hand side stays the same. And I factor out a dy dx. Almost there. Divide both sides by whatever is sitting next to dy dx. So whatever's sitting next to it. So I'm going to divide both sides by 6x minus 3y squared. That whole thing goes away. And here's my answer. 3x squared minus 6y over 6x minus 3y squared. Now let's see, I think I'm supposed to write the equation of a tangent line, so let's figure that out. There we go. We want to find the tangent at the point 3, 3. So first thing I need is my derivative value at the point 3, 3. So everywhere I see x, I plug in 3. Everywhere I see y, I plug in 3. So heck, I'm just plugging in a bunch of 3's. So let's see, I have 3 times 9 minus 6 times 3 over 6 times 3 minus 3 times 9. I think I'm going to get negative 1 here. I have 27 minus 18 over 18 minus 27 gives me negative 1. So let's Desmos this thing. Well, look at that pretty graph. We have our little loop-de-doo, and the point actually is at the end of that little loop, and our line is perfect. And there's the pretty picture.